Hello everybody, my name is Eyan Ven Roy, and today I am in the Mass Spectrometry lab, and we are going to be working on some dilutions of samples that we will then submit to our HPLC MS machine, which stands for High Performance Liquid Chromatography Mass Spectrometry Machine. That's a lot of words, but it's actually a very interesting and very useful tool at our disposal to understand molecules, their fragmentation, and how we can determine their structure using that fragmentation. So in order to do that, specifically for the liquid chromatography machines, instruments, we need to get whatever sample we are analyzing into a liquid state. And in order to do that, we obviously need a solvent. But first and foremost, we're going to determine whatever sample it is we are trying to dissolve in a solvent. That which we want to analyze. So today, this sample is not going through the LC. This is for a different experiment, but it is still going to use the same principles of dilution, and we are still going to go through it in the same way we would with any LCMS sample that we would submit. So this is a Nile red dye for a different experiment, as I've said, and we are going to be diluting it down to a 1 milligram per milliliter solution or concentration for us to get into a working concentration for a future experiment. But the process is, again, the same. So let's get right into it. So the first thing we want to do is obviously get the sample we want to dilute. Like I was saying, this is a Nile red solution, and when we get these samples, typically when we have them in their stock containers, we want to mark the date they were received and the date that they're going to be opened. So that would be today. They were received, it looks like, on June 20th of this year, so not too long ago. Once we have that all marked and annotated, what we're going to do is we're going to get these vials, these 4 milliliter glass vials. Obviously, it doesn't have to be these, but these are what we're using. And we are going to zero them out so that we can determine the weight of our sample we have, and then that's going to be used further down the road to figure out how much of a solvent we need to get it down to a working concentration for us. Okay, so when we're zeroing with these vials, and with any vial in particular, you want to be consistent with your measurements. If you zero it with the cap on, make sure the cap is on once you have your sample in the container. If you don't do it with the cap on, make sure when you have your sample in the container, you weigh it without the cap on, if that makes sense. Just be consistent with your measurements. These little caps have weight, and they will alter your measurements significantly, so make sure to keep track of that. So what we're going to do is we're going to put this on our little scale. I personally like to do it with the cap off. Then they have these little side doors. You're going to slide that close, and you're going to press mode to 0. I don't think this is news to anybody, but we're just going to walk everything through. With these particular scales, we have to be very careful because even a little pressure on the counter can disrupt its measurement process. It can make it be a non-zero measurement. It can add weight to our samples. So we just need to be careful and mindful of that. So try to stay away from it while it's zeroing. And now it's zeroed. We're going to take it out. So we have it here. And we have our sample here. So for that, we're going to get our little spatulas, such as these. And we're going to scrape some out, and we're going to put it into these containers. So anytime, I've been told by a very wise person, that anytime you pick up these tools, and we have a pile of them over here, if you haven't been using it, assume it's unclean. So what we're going to do is we're going to go rinse it with some methanol, dry it off, bring it back, collect some sample, and we'll get back to the measurement. So we've rinsed our spatula, and just for a little pointer here, when you are getting samples, sometimes you'll be getting multiple samples back to back. You want to rinse in between every sample. Use the same side. You want to be consistent. Again, the same thing with the cap on, cap off sort of thing. Be consistent with which side of the spatula you are using. So I like to go with the skinnier side here. There's also this broader side. It's more of a preference thing, but also there are some bottlenecks that you just can't get into with the wider one. So I personally like the skinnier one. Now we're going to pick up our sample here from its stock and our vial here in the other hand, like so. And we are going to try and get some of this material out. And typically for these concentrations, we like to get around 10 milligrams if we can. Sometimes we can't, that's okay, but 10 mgs is about where we want to get. Just going to lightly dispense it there. Now this particular sample is fairly clumpy. So the first thing we want to do is make sure that our stock is all sealed up. So obviously if our stock is contaminated, then it ruins everything, and we have to buy another one. So let's just make sure that's taken care of, that's clean, we don't have to worry about that for right now. Now again, no cap, because we didn't measure it or zero it with the cap on. We're going to put this back on, and our scale is going to give us a measurement here. So once we've weighed it, we were fortunate enough to get right on the dot with 10 milligrams. What we're going to do is we're going to annotate on this blank strip on the side of the vial what it is, when we did it, and how much is in it. And that's just for this first vial that we have. So I've already annotated that it's Nile Red, today's date, and that we have 10 milligrams of our stock solution. So now we're going to determine, based on this weight, what kind of concentration of our solvent we need to dilute this into our working 1 mg per mil concentration. So let's go figure that out. So one point I forgot to mention is sometimes when you're working with these samples, kind of dependent on just their physical properties. For instance, this one is more messy, I'll say. Might be hard to tell, but it just kind of stains the outside of the vial a little bit. And that can kind of make it difficult when getting it into the bottle. It'll kind of stick to the bottleneck depending on its properties again. So in order to combat that, what we traditionally like to do is just get one of these like electronic dusters, spray just clean air. You just hold it away from you and you spray it off. And you want to do this before you measure it, obviously, because all that stuff that's caught in the bottle or on top of the rim is going to be added to your weight. So you want to do that before, not after, just to make sure you have a nice clean measurement for your samples. So if it's a little dirty, just use a little air, but be weary of not blowing all your sample out of it either. Okay, so just something that I forgot to mention. So now we have our solvent, which is going to be DMSO. For this in particular, our Nile Red solution. And since this is a volatile solvent, we're going to be using these positive displacement pipettes. So a little different than a normal micropipette, but altogether virtually the same. Some slight different user things. And now what we're going to do is use this 10 milligrams that we've weighed out. And what we're going to do is we're going to get it down into a working solution. We try to stick with nice even numbers, or just nice clean numbers, I should say. So we have 10 milligrams of this, so what we want to do is get it down into a 5 milligram per milliliter concentration of Nile Red dye in DMSO solvent. So what we're going to do is we have 10 milligrams of Nile Red, and so a nice good concentration for that would be 5 milligrams per milliliter. That way we're using up a good amount of space in these 4 milliliter little glass vials we have. So we divide the 10 milligrams by a 5 milligram per milliliter solution, which leaves us with 2 milliliters of our DMSO solvent that we're going to be putting in to get to our 5 milligram per milliliter solution. And then using that, we're going to get down all the way to 1 milligram per milliliter, and that'll be our working concentration. So we'll start off here by getting about 2 milliliters, not about 2 milliliters, excuse me. Of this DMSO and putting it into our Nile Red. So we have our Nile Red here. We have our DMSO. And with these positive displacement ones, we're just going to make sure that we go all the way down. We rinse the tip a little bit, and then we pull up what we want and dispense it. Now, contrary to regular micropipettes, when we press all the way down, it ejects our tip here. So we want to be mindful of that. Got our concentration here. We made sure there's no air bubbles. And boom. Again, just make sure nice and stable. Expelling all that DMSO. And then we're going to kind of wick the sides, make sure we get all of it out. Want to make sure we're staying as accurate as possible. And then we cap it. And look at that bright red color. That's Nile red dye. Make sure we cap our DMSO solvent, because we're going to be using that again shortly for our 1 milligram per milliliter concentration. And now what we're going to want to do is we're going to go take this to a vortex machine, and we're going to mix it up and make sure that all of the stuff we've weighed out is effectively dissolved in our solvent. So we're going to go vortex that and be right back. So now we have our Nile red 5 milligrams per milliliter solution, and we're going to get it down to our final concentration, like we've been saying all along, to 1 milligram per milliliter solution. So now this is purely a fraction game. So we want to get it to 1 milligram per milliliter from 5 milligrams per milliliter. We want to do a 1 to 5 dilution, which means essentially we take any number and we make our 5 milligram per milliliter solution in this new solution a 1 in 5 ratio, right? So I'm going to pick 3,000 microliters. So 600 microliters are going to be the 5 milligram per milliliter solution of this Nile red we just made up, and 2,400 are going to be of the solvent DMSO. And again, that's to get it down from 1, 600 microliters to 5, 2,400 microliters dilution. So purely a numbers game here. So let's get that ready. I like to put in the solvent first, just in case, That's our 2,400, and now we're going to drop 600 from this. So we're going to cap off our DMSO. Put that off to the side so we don't get the tops mixed up. So that's a problem. And now we're going to get 600 from this. What's nice about the Nile red dye is you can see very clearly if you have air bubbles. Squirt that in there. Cap that on up. And there we have it. This is our 1 mg per mil working solution. So that's how you get your working solution. And again, we could submit this, we could dilute it further so that it's capable for the LCMS. But for this experiment, we're not going to do that. This has just been a brief introduction on how to do serial dilutions in this sort of sense. And yeah, that's how you get a 1 milligram per milliliter working solution. I hope this helped. Don't forget to label these containers with when you filled it up, the concentration of the solution and what the solution is, and what the solvent is. That's important as well. So, enjoy. Good luck with your dilution.